I'd like to welcome you all to our ongoing Conversations with Scientists series, and I'm just delighted and honored to be able to introduce Tony Sinskey today. I met Tony shortly after I came to MIT in 1976, and I think we taught summer courses together, and we did some consulting. In the end, three of my grad students ended up doing postdoctoral work in Tony's lab. And when I first came, we were in building 56, and I was on the 6th floor, but Tony's office was on the first floor. And I discovered one of the most interesting things I could do every day was to stop in Tony's office on my way upstairs. This was pre-internet, pre-Google, but Tony was just as good as having a Google search, because every day I'd come in, he'd be full of interesting things he'd heard from all over the place. I don't know how you got your information, but it was wonderful. Over the years, we've had a shared interest in teaching. Tony's done a lot of teaching, but particularly note that he taught a very popular project lab for years and then rolled over to teaching 718, the course that has the discussion and communication part for students who are doing project lab equivalents. He's also been a really strong member of our undergrad committee for years. Ever since I met Tony, he's really stood out for having an interest in doing applied stuff with biology. And I remember as I got here, recombinant DNA was just starting up, and most people were thinking about cloning insulin and wondering what else you could do with it. But right from the beginning, Tony was thinking of metabolic engineering and how you could use these developing technologies to make all sorts of interesting products. And he's had an enormously successful career. He's published more than 350 papers, and he's got more than 50 patents and 33 grad students. He's a very busy and productive time. Tony's also stood out in my mind because of his interest in international collaborations, and he's done a lot of work, for example, in Malaysia, and I guess recently you got a mega grant and you're running a center in Russia now as well. And Tony's received a number of honors in his career, but I think there's one that's probably singular to him. I saw he recently got an honorary doctorate in biotechnology in Malaysia, and I saw these wonderful photos of Tony in complete Malaysian regalia receiving this award. So,
from the Queen.
So Tony, we're really looking forward to hearing your story.
Well, thanks, Graham. It's a pleasure to be here. This is a hard thing to start and say. So what I thought maybe I'd tell you how I got into where I got to MIT. So I grew up in a little town in Illinois called Collinsville. Only thing it's known for is basketball. And coach there was the most successful basketball coach in the state of Illinois and still holds the records for top 10 basketball coaches. So obviously they wanted me to play basketball, and my father wanted me to play basketball, but I started playing basketball, and you're running up and down this court all day, and God almighty, this is boring. I said, I'd rather read a book. So I quit, which my father never forgave me for. So I used to work every night after school on the farm and things like that. And I was going to high school, and all of a sudden one of the science teachers in math asked, well, what are you going to do after you graduate from high school? I says, well, I don't know. What choices do I have? She says, well, what about college? I says, well, tell me what this college is. I don't know what a college is. And she says, well, that's where you want to go if you want to become a doctor or a scientist or an engineer. Oh, that sounds interesting. So I'll take a look at that. So I did that and started looking at it. And of course, my father wanted me to stay in Southern Illinois and work in this Southern Illinois University and so forth. I didn't know what I learned was usually when my father told me to do something, if I did the opposite, I was better off. So I decided I'll go to a different school. So the year I graduate from high school is 1958. What happens in 1958? That's the year of the Sputnik, right? So everybody wanted to be an engineer, all my classmates and et cetera. And I thought, God, these guys are smarter than I am. I'll never be an engineer and be competitive. So I'll do something different. So I found and looked in the catalog, and I found that there's a field called food science and technology. So I enrolled in this program at the University of Illinois. So I was the first student to ever enroll in this program as a freshman, to tell you how early it was. So I got there in the first day in these big agriculturals, it was in the Department of Agriculture, big agricultural meeting room, and they announced the qualifying exams. And they say, well, we're really pleased. We have one student who's passed the advanced math test, and he gets to take calculus. And that was me. So, oh, wow, this is interesting, you know. So then I started looking at this curriculum and started in the program, and I realized, gee, this is not a good curriculum. And then I decided, well, I'll go to the library. Somebody must have figured this out. Somebody must know what they're doing. So I went to the library and I found that there's this little school called MIT who started a program on, quote, food technology. And it was a spin out of the Department of Biology and Public Health at that time. Interestingly enough, those two departments were all together with Harvard School of Public Health. So I said, well, I'll follow their curriculum and maybe I'll learn something. And that time at MIT was 2 years of math, 2 years of physics, 2 years of chemistry, 2 years of humanity. Okay, I can do that. And then I'll take whatever is necessary. So I followed that, and et cetera. In the meantime, however, this Illinois, you had to take military training. I had to take ROTC. And so I had a choice, either the Air Force or the Army. I decided I'll take the Air Force. That sounds more intellectually driven, and so they grade you, and the grade goes on your cumulative average in those days. So the first term I get a B, the second term I get a C, the third term I get a D, and the fourth term I didn't think the guy would have the nerve to flunk me. You know, my last term he flunked, but the bum flunked me. I could still see the guy flunking me in the face with his little pipe on and so forth and so on. So I hated that. I mean, I hated that military so much. So I was a really bad student. And then they had these parades. And I was asked, you had to march in the line and bunch of 50, 100 people marching together. And I was the only guy in step. Everybody else was out of step. And then they asked me, well, why don't you carry the flag? You can march by yourself up there. And then I would go where I wanted to go with the flag. And then finally they asked me, would you just stay home when we have a parade? So then I had to take the course over again. I went into the Army, and that was useful. I learned how to operate a radio. I learned how to shoot a gun and Morse code and things like that. So I finally got through that. And then the other grading thing that you had to do was physical education. So you may not appreciate it now. When I was in college, I was very thin, and I was like a rail. So I wanted to take a course in weightlifting. And a course in weightlifting, they grade you. So I went through a whole series of optimizing the weights that I could do and the lifting so I could get a B. And then I went home for Thanksgiving holiday and came back, and I was in a new weight class. So I went into a C there because of my mom. Anyway, I was also working in college, and I was a dishwasher, first in a dining hall, and that was the worst job in the world. So from scraping off trays and things like that, and I said, Jesus, there's got to be something better than this. So from the dishwasher, I graduated to operating a machine to wash glasses. That was my step up. Then I went to my advisor and I told him, you know, I'm really miserable. All I'm doing is going to classes and washing dishes. There's got to be something better than that. He says, well, why don't you come in my lab and start washing dishes for me in the lab? So okay, that sounds better. I start washing dishes in this lab. It was a microbiology lab. And I didn't understand, what are these people doing with these dishes all the time? Every day I would come in there and there would be a tray of dishes and I have to go wash them. What are they doing with all this stuff? So I started figuring out, I asked the people, what are you doing? Why are you using this and why are you using that? And except, so then there was a visiting professor there from Denmark, and he was in there all the time. And I started going in there on Sundays and Saturdays, and he was working. He started teaching me how to do science. Started telling me about microbial spores and heat resistance and calcium dipicolinic acid, and he was just really a great guy. And so he taught me how to make medium, how to do dilutions. We have a kid in the lab now who's a brilliant student here at MIT having a hard time making dilutions, so it's fun to see this. So from that, I decided, well, I'm going to go to graduate school. And I applied to only one school, and that was MIT. So I get to here at MIT, and I decided, Jesus, they have the same problem. It wasn't a rigorous, it was a good curriculum in food science and so forth. It was good, okay, but it wasn't rigorous. So I decided I'll take the whole curriculum of chemical engineering. So I started with 1012, 1013, 10301, 10302, 10033, differential equations, et cetera. I took all these courses, and one course I took was 1040. That was the hardest course I ever took in my life, thermodynamics. And there was a big guy sitting in the front row all the time, my size, my shape, same color of hair. And I couldn't understand how he could be passing the class. I'm struggling, I'm working hard. I could answer a question or two, but he couldn't do anything. So I had my first consulting job with a company called Abcor. Abcor was formed by Ray Badur in chemical engineering and a man named Dick Crowley. So they invited me to the Christmas party. So I go to this Christmas party, and I have a suit on, and I look pretty respectable, and I put on a name tag in this Christmas party. All these people come to see me. And then they look at my name tag, and they read my name tag, and they walk away. And then I realized, aha, they're looking for somebody else. So a few minutes later, this fellow in my class comes in with two blondes on his arm, walking in the room and so forth. And so I said, well, I'll go over and see what his name tag is. And his name tag was Billy Koch. And his brother, David Koch, in the thing, he was my classmate. So I told David the story about it. And he says, I believe every word. So I did okay in research. Research with MIT was just so great. But there were two things that struck me at MIT when I walked into MIT the first time. One, there was no black students. My roommates were black students, and I had athletes as roommates who, the coaches would come to the athletes at University of Illinois and tell them, you'll pass the exam if you get the veins blue and the arteries red in coloring. So that's where it was. So there was only two, and that was in the Ashdown House. And the second thing, I walked in the first lab, and I started talking to the graduate student, and I thought, aha, this guy is not so smart. I'm going to do okay here. And I thought, well, gee, I'll be competitive after meeting that first graduate student. So I found out doing research at MIT was fantastic. Resources, facilities, do what you want. So I think by the time I was finishing my PhD, I maybe had 10 or 15 papers published on various topics. So then MIT asked me to go and study virology. Okay, where am I going to study virology? Well, we want you to study virology about foods. And the only place you can really learn about foods and virology is at Plum Island. What the hell is Plum Island? So that's some place in New York that you have to take a ferry to. So, okay, I'll take a look there. And I get on this ferry, and I realize it's a high security place to control infectious agents in the US. And they wanted me to work on foot and mouth disease. So I go there, and I pass the interview, and they say, well, we'll take you. You're not a virologist, but we'll deal with you. And so I go there, and they tell me, well, how do I get here? He says, well, you take a ferry every day. And then you go into this room, you change your clothes, you shower, you put on a new suit of clothes, and then you do your work. You do routine coming back. You have to go through sodium hydroxide, wash all your glasses and stuff like that. And I decided, I'll never make the ferry. I'll miss the ferries. I'll be stuck on this island for the rest of my life. So I decided, well, I'll go to Harvard School of Public Health. So I went to Harvard School of Public Health, and I met a man named Chang. And some of you, it's the Chang liver cells. And he was trying for the life of him to isolate the virus that causes infectious hepatitis, which he never did. But he gave me this project to work on a virus called the vacuolating virus, which was just isolated out of African green monkeys from production of polio. And this virus was called vacuolating because it formed these foamy structures in the cell line. So I isolated this virus and I transformed human immune cells. It was the first transformation of human cells with SV virus, and I did these beautiful experiments with the T antigens and the imaging under the microscope. And then I took that preparation to transform cells and I injected it in the hamster. And these hamsters got the biggest tumors I ever saw in my life. And I said, gee, I'm not playing with this anymore. This is scary. Unfortunately, Phil Scharf came along and worked out the molecular biology and all that. So I came back here to MIT and started in virology, which was really slow. I mean, I was spending all my time changing media and working on these viruses. So I decided, well, I got to do something different. So I started looking at various types of projects. And Graham is absolutely right. My office was on the first floor of Building 56, and it was the best thing I ever had going, because everybody would go into the parking lot and would pass by my office door. So in the morning, I'd keep it open. People would stop and we'd chat. At maybe 10 o'clock, I'd shut the door and do what I do. And then in the evening, I'd open up again, and people would stop and chat. And that's how I learned all chemists, biologists, David Baltimore, Harvey Lodish. Harvey and I started at MIT about the same time, actually. He worked on xylose metabolism, as I remember right, for your PhD.
Glycoprotein.
Yeah.
Actually, no xylose, but lots of exotic sugars.
Right. He worked on sugar metabolism. So I had these two graduate students. We were working on modifying DNA, and I kept on asking, what are you doing? He says, oh, we're trying to engineer DNA, and we're buying these enzymes. Why are you buying all these enzymes? Why are they costing all this money? Oh, these are the best reagents for cutting DNA and re-engineering constructs, and we're going to solve all kinds of world's problems. So show me where you're buying these from. So they gave me the catalog. The catalog was the most beautiful catalog I ever saw. Had a beautiful sunset in it, similar to your rainbow thing. And it was a company called BRL. So I decided, well, maybe I ought to go find out what these guys are doing. So I go down there, and these guys are selling enzymes out of buckets, ice buckets, going around the various universities. I said, well, this field's going to be really a big field. These guys can go around selling these reagents out of ice buckets. So then I wrote a proposal to the Office of Technology Assessment saying, I'd like to study the impact of recombinant DNA in the food, chemical, and pharmaceutical industry. So I just wrote it down and forgot about it. Then I wrote a proposal in the Navy on how to use recombinant DNA for dolphins to see how they can be missile seekers and stuff like that. Crazy ideas. I wrote one to the NOAA on fish and fish farming and growth, and I wrote one on fish feeding and nutrients and so forth and so on. So it went on like that. Then all of a sudden, the Office of Technology Assessment calls me up and says, we're going to fund your project with one proviso. You have to have somebody from Wall Street help you do this analysis. So I didn't know anybody on Wall Street or where Wall Street was. I knew it was in New York, but that was about it. So fortunately, I have a brother-in-law that worked in Wall Street. So I walk into his office and I explain this project to him, and he tells me, I don't have a clue of what you're talking about. But if you want to do this project, I'll pay for a person to come and work with you from Harvard who was a chemist by the name of Scott King. I don't know if you remember Scott. So he came there and we did this study. And I found out Wall Street didn't know what they were doing, and I found out the industry didn't know what they were doing. That was interesting stuff. So two graduate students and I did the whole report. And then we had this conference at MIT, which still is the biggest conference ever held at MIT. It was standing room only. It was the day Genentech went public. It's the day Wally Gilbert got the Nobel Prize. It's the day Sanger got the co-Nobel Prize. And I remember distinctly Harvey's lecture in this little course saying, basically, recombinant protein production from microbial systems is not going to be the answer because you need glycoproteins for stability and blood currents, and that's all held up. So it was a great thing to do. So I got interested in analyzing this field. And then at MIT, I had a call from one of the programs of USAID, and they had a program in Egypt. And a faculty member comes to me and says, we need you to go to Egypt to meet with the Secretary of Agriculture in Egypt. And what is his problem? He says, well, he's got a problem with spoilage of tomatoes. Would you go take a look at it? Oh, sure, I'll go. Take a ride to Egypt. Then I decided I'll do some literature search to see if there's any infectious diseases with tomatoes. Maybe I'll find some microbial problem to work on and so forth. And I went, and that was just at the time when plasmids were starting to be isolated out of microorganisms and being associated with resistance to antibiotics or plants or behavioral environmental responses. So I go to Egypt, see the pyramids, try to ride a camel, which I found unstable. But I meet with the Secretary of Agriculture. He tells me, what's your problem? He says, well, I got these spoilage problem with tomatoes. Now, I didn't tell him I hated tomatoes. I mean, I used to grow 10,000 tomato plants, and that's a pain. Fingers are green and rotten tomatoes. So I hate tomatoes. I just started eating tomatoes. That's how bad I am. So then I go and he tells me, well, we put our tomatoes in these little wooden baskets, and these little wooden baskets have little splinters on them. They puncture the tomatoes, and then we have spoilage. I said, well, the problem's simple. Just change the baskets. Let's get some plastic ones in here, and you're done. So that would solve that problem. So I came back here, and I was supposed to teach a course in food microbiology, and there weren't any students enrolled in it except one who had to take the course. So I said, why don't we do a special talk? I want you to go and find out all you can about plasmids in a bacterium called Corynebacterium glutamigo. The student comes back to me and says, there is no plasmids. There's no reports of them. I said, well, I don't believe you. Let's get some strains and let's start finding some plasmids. So I started playing with plasmids in this bacterium, Corynebacterium, and I isolated one. And then I said, well, gee, I'm going to make a vector for transformation. So Graham came down and told me how to make vectors and so forth. So this was the day when the dogma was gram-positive genes had to go into gram-positive organisms and so forth. And I figured, well, let's try some E. coli stuff, and it worked like a charm. So Graham and I developed these vectors for Corynebacterium. And that became a whole field for amino acid production. I think we generate 50 to 100 papers in this general area. And much of the world's supply of lysine is made by these vectors and strains, based upon this trip to Egypt and the person there. So the other thing I did was always keep my office door open because you never know. And I had the philosophy, still do, but now I'm on the third floor. The only people that come in third floor are people that look to rob the place, not to. So I decided, well, I'll keep it open because you never know when somebody will come in and offer you research money. So one day a fellow knocks on my door and he says, I want to give a grant to MIT to use unnatural sugars for single cell protein. Oh, fine, we're the right place for you. So we started a research program. I think he gave us $1 million from the Strauss Foundation, which historically is interesting. And then Graham and I had a project with W.R. Grace on making vectors for amino acid production, because what I figured out, this technology could bypass all the Japanese intellectual property on making amino acids. So a fellow from W.R. Grace walks into my office and he says, well, you've been working on this little project. I'd like to give MIT now $10 million. Oh, God, this is real money. So I said, oh, gee, this is out of my pay grade a little bit. So I decided, well, I'll call the provost's office, and the provost sends some assistant over. We go to lunch. The guy puts on his little piece of paper, okay, I want to give $10 million. This is how I want to do it, and et cetera. And that was the last I saw of the $10 million. I mean, it went into the provost's office and it became study and everything. But it did a lot for MIT and microbiology. And then, as Graham was mentioning, we did a lot on anaerobic microbiology and science, and I worked on bacteria, Corynebacterium, to make molecules that people thought you couldn't make and still have trouble making. But one of them we worked out, so we taught together. And I had this German scientist, Rolf Tauer, come to me, and he would give lectures. And he's a brilliant methanogen fellow coming to give lectures. And he's the one who worked out the structures, the nickel structures of methanogens with Eschemoser in Switzerland. So at this time, Matsumuni comes through my door and he asks, how are carbon-carbon bonds formed in biological systems? And I tell Sat, gee, I don't know. Why don't we write his name was Sat, they called him Sat. Why don't we write a grant? He says, okay. He says, we're going to work with a bacterium called Zuguliola ramagira. Oh, I know that bacterium. I work with it all the time. We do all kinds of research on that because it was an interesting exopolysaccharide produced. So my friend from Germany tells me, if you're going to collaborate with a chemist, you should make sure you collaborate with a good one. So I go to Masamune and I say, Sat, I have to ask you a question. What's the question? How good a chemist are you? Where would you rank yourself on the top 10 chemists of the world? And he said, okay, that's a good question. I would rank myself number 3 in the world. Oh, okay. Now, I didn't have the heart to ask him who the top 2 were. But I think the top 2 was Woodward, who was a graduate of MIT in chemistry, as you well know. And the other one was Kishi, the Japanese professor at Harvard. I think those are the 2 he had in mind. So and the reason he was interested in carbon-carbon bond formation, he was the chemist who figured out the structures of the antibiotics, erythromycins, all these antibiotics put together with C2 units or C3 units, and he didn't know how that biochemistry took place. So I isolated the first enzyme in this pathway, which is a thiolase for carbon-carbon bond formation. We used, since we had the bacteria, we made a protein, purified it, and made an antibody, and we used Rich Young's technology for lambda phage expression and antibody cloning for a positive clone, and it worked like a charm. And then the thing I realized, why do these chemists want to collaborate with me, right? And what I realized is they didn't understand this recombinant DNA technology, and it just drove Matsumune up the wall, because in biology, recombinant DNA technology, you can amplify to get purity. The chemists, to get purity, they got to take everything away. So he just didn't understand this concept. Anyway, I controlled the clone. Since they didn't know how to do recombinant DNA technology, I collaborated with Chris Walsh and George Whitesides and all these fellows, and we had a great time. And then we had it on the thiolase project, we had 15 postdocs working, including Barbara Imparelli, who did her partial PhD thesis topic on that program. And then she was a brilliant chemist. I wrote a letter for her postdocs and everything, and it's been stellar ever since. Then we couldn't crystallize a protein. And so then we decided, well, I'll look at the next enzyme in the pathway. Then the next enzyme in the pathway was a reduction to form acetoacetyl-CoA. And then, well, okay, we did that, cloned it, characterized it, did the enzyme. Then the next enzyme was an enzyme to put the hydroxybutyrate into a polymer to make a storage molecule. And there was a company called ICI through MIT came to me, and I said, I'd like to work on this problem of making this polymer, and I think I can improve your process by isolating this gene and putting it into a different, more useful production organism. And this guy, I could still see him sitting in that room, told me something, which as young people I want you to remember. He told me, the problem is too difficult, especially for you. And if it's going to be solved, it's got to be solved by somebody smarter than you. Oh, okay. If that's the way you want it, I'll show you. So we went out and we solved that problem. So don't be afraid of a hard problem when somebody tells you you can't do it. And out of that became the concept of making biopolymers and biodegradable plastics. The end result of that has been a lot of good science with Joanne Stubbe, Chris Walsh, international collaborations, a laboratory in Siberia that we work on this. But more importantly, I think there's 400,000 patients that have been using these biodegradable sutures because it's so effective in preventing infections, and especially if you have hernia operations. So that problem has morphed into me understanding and being very interested in CO2 metabolism, and that's where I continue on today. What I found at MIT is one great place to be. You guys should enjoy it while you can, because you can almost do anything you want at MIT as long as it's not a crime. You could do science, you can teach, you can interact with people, and I think the faculty here at MIT are just spectacular to interact with. And so I've had a lot of great times with the faculty. But getting back to this technical assessment we did for the US government, we had this big symposium, and then I was sitting on all this knowledge, and I said, well, what the hell am I going to do with all this? All these opportunities and so forth. So I got a group of MIT colleagues, and we formed a little discussion group, if I would use this, and we started doing interactions with the outside world a little bit. And one of our first projects was with a company called Genzyme. And the founder of Genzyme calls me up, and he says, I want you guys to evaluate a potential scientific advisory board for me from a local university. So I call up Harvey and I says, Harvey, can we do this? And Harvey says, oh, sure, no problem. But he tells me, make sure they give us a check in advance because they may not have any money the next day. So Harvey and I go there, and the fellow comes in the room, and with Harvey being on target, the guy breaks out in a cold sweat. And you can imagine what the answer is going to be, right, before he even starts. The group is not world class. So that was the end of the story. And by the way, we want to make sure the check clears today. So that's how the conversation is. So then the fellow comes back and says, well, why don't you form a group to become the advisors for Genzyme? I says, okay, that sounds interesting. So I meet the founder of Genzyme. I said, look, I don't like to negotiate. I don't like to talk to people much. You make one offer, and if my guys like it, including one lady, we'll do it. And he came back and he made a fantastic offer. So, okay, we did it for you. And then Genzyme was not the premier biotechnology group because it wasn't really molecular biology so much. We had a lot of chemistry input, which was pretty misguided, tartaric acid and things like that. It was sort of silly, really. We had hyaluronic acid, and that technology now has led to $1 billion in sales at Genzymes, which came out of MIT, interestingly enough. But Genzyme was so poor, it had all kinds of government contracts, and one contract it had was to purify ceridase, an enzyme for NIH. And to attract a CEO of a company, we interviewed many CEOs. And at that time, I shouldn't let you know a quirk of my personality, but I always thought at those times that Harvard Business School was a KGB plot to break down the economy of the U.S. So I would not hire anybody that had a Harvard Business School degree. There's no, it couldn't go in the room. So we met this fellow from Holland who had a master's degree in business administration from Virginia. Okay, that sounds good to me. So we interviewed him, and he made him an offer, and he accepted the job, which he now is on the executive committee of the MIT Corporation on the biology visiting committee and so forth, a very successful person. But to attract him, we would go around the various hospitals collecting placenta and processing placenta into materials for isolating this enzyme called ceridase. So in the evening, he got the placenta car to drive around in for his transportation. And I was riding with him one day, and the Whitehead Institute was going up. And he tells me, you know, someday we'll have buildings bigger than that. And then I thought, my God, what is this guy smoking? I mean, this is unbelievable. I mean, he had a vision, so. But Harvey and I and Graham, we met with him for 6 months solid to work out a strategy, and he followed that completely. But the exciting thing was, we went to Eastman Kodak, and we were going to make a presentation about how to make enzymes and things like this. And Eastman Kodak said, we think you stink and we're not going to support you. A little company, you're unreliable, you can't provide reagents. So there was a snowstorm, so I asked Henry, two Henrys, what are we going to do now? We're shut out here. And Henry says, we're going to make ceridase. Well, why are we going to make ceridase? Harvey tells me that gene therapy is going to replace this ceridase for Gaucher's disease, and there's no future in it. He says, no, I know there's a big future in it, because he knew the hemophiliac market. So in that little airport in Rochester, New York, that's when the decision was made to make ceridase as an orphan drug. And we brought a patient in, a young boy who had Gaucher's disease by the name of Brian. And they gave him the first dose, and it cleared too fast. And Harvey sitting there says, well, it's being cleared too fast, and we need to put some carbohydrate on it. So he had some ideas and put the carbohydrate on it. And that became the basis for that orphan drug and Genzyme. So that clinical trial was done on 6 patients. That's all it was, and out of that whole big business. So that was a good run in science, and we had a great time together. Harvey and I traveled to France with Dan and Yogurt business, and I took him to one of these big breweries, and he was asking, what are those big tanks for, and stuff like that. So it was exciting. But in the end, what I have found really fun to do is form interdisciplinary programs to interact with. So most people don't realize that, but I did catalyze the first big enzyme engineering grant here at MIT. I was very instrumental in getting the biotechnology processing engineering grant for cell culture engineering, and developed the first academic programs in cell culture engineering, as well as conferences. And after a while, I don't have a great attention span, so I get bored, so I look for something else. So right now, what we're doing is we're trying to develop new tools to make basically synthetic organisms to improve fermentation processes, and working on an international collaboration to do this with George Church and people in synthetic biology here at MIT, people in Germany, people in Oxford and Cambridge. And it's a challenge to be able to do that. We've had a big ARPA-E grant on how to make biofuels, and I'm really happy that Chinnan's poster in the biology retreat was one of the best poster awards that she got in this area. So that's been fun to see happen. And then we're very interested now in CO2 and CO2 in various types of global issues, especially the biology of CO2. And then I run this center called the Center for Biomedical Innovation, which MIT hired this big name drug person to come in to run a center for MIT on drug development and healthcare. And no matter what I told him, I kept on telling him, you're going to fail. Well, why am I fail? I ran $1 billion program. I says, you can have $1 billion, you can have $10. If you have no program with MIT faculty, you're screwed. Nothing works here. There's only two things that matter at MIT. Who's your faculty colleagues and what's the account number, right? That's the only thing you need to know. And you can't do anything at MIT unless you have an account number. So then the provost, associate provost, asked me to take over this center. And we were $1 million in the hole. This guy went through $1 million of MIT's money. So I says, well, gee, I can't pay back $1 million. You have to give me some money to get it going. He says, okay, we'll forget about the million, but just give me a buffer in case I get in trouble. I'll solve this problem. So we built it to a pretty effective center at MIT in manufacturing, in drug design, into an interdisciplinary program. We have a significant program with Sanofi on innovation. We run 12 different portfolio projects. And it turns out the evaluation is just and what I realized, what distinguishes MIT from Harvard, they have a similar program at Harvard. They just took the MIT agreement and put Harvard in it, copied it all. It was the most efficient agreement they ever negotiated at Harvard. But what makes MIT different is the engineering sciences and biology working together become very effective. So they just did an outside evaluation, and our program clearly ranks #1. Now they don't know what to do with it, right? How do you give us more money and things like that? So we'll see what happens. So that's sort of what I do. I don't know how long I'm supposed to talk. I'm sort of programmed for 45 minutes. But I'll tell you one thing. What I really enjoy on the Corynebacterium project, I had a postdoc tell me he worked out the transformation of Corynebacterium glutamicum. I looked under the microscope and I saw it was Staph aureus, and I says, you're out of here if you don't know this organism versus Corynebacterium. And then to work out the transformation, I went out and found an MIT undergraduate. And this undergraduate came to me and she says, oh, I'll work this out. And the beauty of it, she was unbiased by facts. She worked out a strategy. She says, well, if I have to get DNA, I'll have to have a selectable marker, okay? Then I'll have to weaken the cell. And I'll grow it in medium that the cell wall can't form so well. And so she comes to me one day and says, look, I got transformers. It works like a charm. So when I've had tough problems, MIT undergraduates have always come through. And on our threonine pathway, it was an MIT undergraduate taking genes course on looking at threonine metabolism under anaerobic conditions, comes to me and tells me, I know how we can make threonine really neat. And she's now a faculty member here or some other place and this type of thing. So the MIT undergraduates and clearly the graduate students have been great to work with. Some of the students and postdocs have gone on to do great things. Probably one of the most successful is a man named Michael Jetton. Those in the microbiology field will realize he's like Mr. Microbiology in Europe and was knighted by the Queen of in Netherlands just recently for his science. And he works on these bacteria called Ammonox. And as a postdoc here, in 2 years, he published 14 papers, and it was phenomenal. So the attraction of MIT is you have phenomenal people to deal with. And for the most part, if you let them do what they want to do, you can really have a great time with them and have a lot of fun. So that's where I've been at MIT, and I've enjoyed every bit of my colleagues, and Jonathan on the floor, and Monty and Graham. and Harvey and Gene and so forth. So thank you.
I think we still have time for a few questions if there are some things that people would like to ask.
Tony, I was wondering what you consider to be the biggest challenge of your career. What was the biggest challenge?
Surviving. My challenges have usually risen out of having research money and having money to do things. But one has been great with MIT. MIT has trusted me. So I think that's the hardest thing here is raising research money. It's harder now than it used to be because remember when I started, that was at the great days of NIH and money was just rolling in and so forth. Now it's very competitive, more competitive than it was. That's a great challenge. I don't think tenure was a challenge at all because I did something very useful. I took my PhD thesis and that was an era when we were working on single-cell protein to feed the world protein supply. And to use single-cell protein, you had to reduce the nucleic acids. So I knew how to do that by giving a little heat shock. So that became a very effective process. And I don't know if any of you have gone to England and had any of this fungal protein chicken, vegetarian chicken. That all is used as the process I developed to remove nucleic acids in this. It was licensed from MIT, royalty-free and so forth. And it was sort of, so that's what I solved. So I did that because it was easy. I think my greatest challenge is I'm not a great writer. I can't write well. People like Harvey and George Whiteside say, when they grew up, I think their hands were slapped in writing, so they went all to these private schools and so forth. I just went to a hick school in Illinois. So I think writing is my greatest challenge. I'm not good in administration. I've been on every committee at MIT that you can think of. I was chairman of the radiation committee. You may not appreciate it, but I prevented mouth pipetting of P32, which people used to mouth pipette P32 with little U-tubes. I prevented all that business and safety. I ran a radiation service here, Cobalt 60, and I got tired of doing that because it was a big hole in the ground with 12 feet of water, and every Nobel Prize winner from MIT was always parking into space where the fire department had to go. And I had to call these guys up and tell them, you move your car, I'm gonna get it towed. So I got tired of doing that. So I decided, let's just sell the thing. We sent it to Israel to get rid of it. And so then my gamma source, I think Bob Horowitz took it and uses it.
You taught Project Lab for a lot of years, and I wonder how I think that sort of wove in and out of your
Project
research
Lab.
efforts. I wonder if you could say a word about that.
Oh, yeah. So I shouldn't say this in front of higher authorities like Gene, but so teaching at MIT can be a real pain, right? I mean, these undergraduates are so smart and capable and critical. So I decided, well, maybe in Project Lab, what I'll have them is teach me. So I decided, well, I need mutants for this. So for this type of problem, you isolate mutants and characterize them. So it became a mill for me getting reagents from my lab. So that's where we got all the basic Corynebacterian mutants that we would do various types of experiments. Then the good students in the lab would become work up there in Europe. So it became a screening program. So that worked well. And then in the communication class, oh my God, what do I know about communications and so forth? And the only reason I did the communication, Chris Kaiser came up to my office and said, would you do this for me? I said, nobody wants to do it. I said, sure, I'll do it for you. I didn't realize what I said yes to. But, so I just said, well, and then we teach with Mary Lou, I got to turn this around. I got to figure out how to have the undergraduates communicate to me and teaching. And so the undergraduates in this 718 turns out to be a beautiful course. You know why it's a beautiful course? I get this insight of what's going on in 10 or 15 labs at MIT. I see the quality of the science, I see how the labs work, get new ideas. Rudolf Janisch is working on stem cells, and I have some trouble with some labs, what they do, but for the most part, it's been pretty exciting. So it's a tremendous learning experience with the MIT student. 721, I still haven't got that.
This is microbial physiology.
Yeah, I still haven't figured out how to teach that properly yet. I get reasonably good rankings in other courses, except these kids in 721. They give Graham better rankings than me, but I think I do a better job than Graham, but he has such a reputation with the undergraduates but we turned it around to a learning experience for the students, and I don't know, some of you I see have taken the course, and it's sort of a fun class now. But I still haven't figured out how to teach it properly, I believe. Harvey, you had a comment you want?
No, I was just thinking they might be interested in the time. This BIA was this consulting group,
Right.
It's 8 faculty with the 3 of us and some others. This ill-fated attempt to set up a antibiotic production company in China.
Oh, that was grim.
I mean, we had you had Stone and Webster building the damn building.
Yeah, right. No, so that's a funny story. You know. So when I was an undergraduate at University of Illinois, I got a summer job. I worked at a starch company called the Union Starch Company in Granite City, Illinois, and the director of research there, which I can't remember his last name, but he was from MIT. Oh, God, he was a biochemist. He did his PhD with Jack Buchanan. So he's sitting there in this little hick town in Granite City, Illinois, and he tells me, you should go to MIT. And so I worked in this starch company. I went around in this old buildings. It was decrepit. It was primitive. They were separating starch by letting starch float on tables. So I was at another meeting with someplace, and a fellow from Miles Lab comes to me, and he tells me, what are you doing? Oh, I'm doing research at MIT. And he says, I'm interested in starch processing enzymes. And do you know anything about a starch company in Illinois called Union Starch? I says, oh, I do. He says, well, we're thinking about buying that company. I says, I wouldn't buy that company for nothing. I mean, you couldn't give me that company. So he was working for Miles Labs. And he says, okay. So I told him not to buy it. Unfortunately, management went ahead and bought it, and they lost their share. But one day I was sitting at a meeting here at MIT, and this Chinese guy was looking at me. Very strange. And he says, come over here. He says, do you want to go to China? This was right after the Cultural Revolution. So why do you want me to go to China? Oh, I want you to go there and give a series of lectures. Okay. So I said, I'm not going to go by myself. I need somebody to go with me. So I couldn't take Danny Wong because they didn't want Chinese. So I took Charlie Cooney. So Charlie Cooney and I go to China, and it was like the Wild West, and everybody, I couldn't tell the difference between the men and the women because they all had the same uniform. When we land there, there's 600 people following us, looking at us, walking, et cetera. So Charlie and I start on this lecture series, and we end up at the Long March Pharmaceutical Company. The Long March Pharmaceutical Company tells us that they want to modernize their antibiotic plant. So Charlie says, oh, we can do that, no problem. So we start a project, and it was so primitive. Their filters were made out of rags, and it's amazing that they didn't kill people that we were doing that. So Charlie and I started on this project. So then Charlie and I went, and I should not admit this among my colleagues, but it's being recorded, right? Well, so Charlie and I spent and $50,000, Harvey, going to China, trying to work out this program with them. And we finally have a delegation of Chinese come to MIT, and they're going to sign this agreement. They come to MIT and they tell us, I don't think the electricity runs here 24 hours a day, does it really? Oh, yes, it does. Don't worry. I took them to New York, to World Tower Center to have dinner, and oh, it was embarrassing because I didn't realize there's a style of eating fish where you spit out the bones on the floor. So in the World Tower Center, we're spitting out bones in this meeting. So it comes to sign the agreement with the Chinese, and they're building this new plant. And Charlie and I negotiated. If you know Charlie Cooney, he's the most smoothest person, non-excitable person you can deal with. We get to the final contract, and the man from China says, okay, now I have a daughter who I want to send to the school to the United States. And I notice you have a Rolex watch on. And I think that I like to have a Rolex watch, and I'd like to have the tuition for my daughter paid. And Charlie says, we don't do those kind of things. We'll see you later. And so then he went, this Chinese fellow, he went to the competing group in New Jersey, and the guy in New Jersey paid for his tuition and gave him the watch. And that was the end of our story in China. So we went from Cambridge to China. We went also to, we had a big program in Brazil. I'll finish my Brazil story. I got a meeting with the governor of Amazon to form a program in biotechnology in the Amazon. Oh, that sounds exciting. So I get there and I go there and I form this agreement. I sign this agreement on national television, the equivalent of the Johnny Carson show in Brazil, with the governor. And he signs it in all kinds of fanfare and et cetera. Then I ask, well, where's the money? Oh, we'll send you the money. So they send us a little bit of money, $250,000. I took it and I gave it to 10 faculty members for a grant to start a program. Then the next phase of money, the governor was somewhat corrupt, and he had built a stadium, and the stadium collapsed, $80 million. And so he defaulted on the money. So one day I was walking in New York City, and I saw the governor from Amazon coming down the street, and he was coming right for me. And he saw me, and he probably had a bodyguard with him. He saw me, and I think he was thinking I was going to go after him for the money that he owed MIT, and he ran to the other side. And that was the end of that story.
Well, I think for the record, I'm not sure if you said Henry Termeer was the CEO.
Yeah,
The CEO
Henry
of Genzyme,
Termeer.
I'm not sure if that made it on onto the story.
By the way, he's fantastic and extremely supportive of the biology
A
department.
member of our visiting committee.
Yeah.
Anyway, I think you get the idea. Tony could go on with stories forever, but Tony, thank you so much, and join me. Thank you.